Welcome to all. Today we will be discussing data mining and its applications. Uh, this is one of the last segments of the first unit. And from the next session onwards, we will be moving to RGB databases, which is coming under the second unit. In case of data mining, you're all familiar with the terms bits and bytes because the language of the computer is actually always the decimal values, zeros and ones. Usually, uh, uh, we know that bits are the basic units of the computer storage, and bytes were actually 8 bits. You know that. Then the terms like kilobytes, megabytes, gigabytes, terabytes, petabytes, etc. were more popular terms nowadays because even your own computer, most of us have a computer with 1 TB hard disk or an external hard disk. And our mobile is having many GBs of capacity, even our mobile devices and the memory card storage devices, etc. This is an average capacity of the storage devices nowadays use in GBs and TBs. Whereas there was a stage in 1998 when I joined for my PG program in Cambridge in the Calcutta University. In the same department of life sciences is having a computer at the time, a single computer, and that system, which was working on that is a Windows 3.1 or something. That's a primitive version of the Windows, even we call Windows 95. And that computer is having a entire storage capacity or a hard disk of 450 MB. That was the maximum capacity of the computer, 450 MB. Even 1 GB was not there for a hard disk. And we used to store our data in floppy disk, which is having a capacity of 1.4 MB. Now, all of you has many pen drives with 128 or 256 GB in your pocket, and you have hard disk with terabytes of storage, internal or external hard disk with terabytes of storage. So you can imagine a condition when about 20, 23 years back, in the same department is having a maximum capacity of storage of 450 MB. And now we have mobile systems with many GBs or hundreds or 256 GB of storage capacity. That type of mobile devices are nowadays available. So within a short span of 20 to 23 years, you know that the data storage capacity has increased that much, and that's also associated with the increase in the size of the data. At the time, maybe our data at 1998 maybe very much less, and that was sufficient. Or for 50 GB computer hard disk was sufficient for the department. But now, even terabytes of data individually, it may not be sufficient, and we may require to increase our data storage capacity periodically because of the increasing demands to storage our increasing volumes of the data. Okay. So I'm just showing you these terms, and there are other terms that like petabyte or exabyte or zettabyte, yottabyte, etc., which are again higher order of capacities, 10 raised to 5. Oh, sorry, 1,000 raised to raised to 1,000 raised to 5, 1,000 raised to 6, etc. So everything is multiplied 1,000 times at every stage. So that type of increased capacity storage devices are also it's not a single device; it's a collection of storage devices that are nowadays available. And such larger server farms of companies like Google or such cloud storage companies were having petabytes of data storage capacity in their firms. Okay, so and in this slide, I'm just introducing you the various capacities of the storage devices And when we come to this slide, you can see that there was in 1986 about 2.6 exabytes of data were existing, and that data was stored in analog forms, maybe books or some tapes, etc. There are all storage devices like analog devices, whereas only zero point zero 0.02 exabytes of data were available at the time in digital format. When we come to 1993 to 2000 period, we have such a device like electromagnetic tapes, analog storage devices of tapes. Again, the storage capacity were mainly focused on such analog devices, not on digital devices. But from 1993 onwards, there is an increase in the capacity of the digital devices, like floppy disk and hard disk, etc. Now, from 2002 onwards, there is a new era, beginning of the digital age, starts about at the period of 2002 to 2002, that period. Then there is a logarithmic increase in the digital storage capacity, which almost eliminated the devices like analog devices previously used before 2000. And now we can see that only about this graph is an old one because it shows only up to 2007, about 15 years back. At that time, by 2007 itself, you can see that the analog devices were only very small percentage of about that's about 19 exabytes of the data, which includes the paper, film, and audio tapes, etc. Then analog video tapes, etc. Where the main storage devices that is coming under the analog category. Whereas we have 280 exabytes of digital data were stored by the time of 2007. So within a short period of about 5 years, there is a very large, high increase in the digital storage capacity, and within about 5 years, that storage capacity has increased to about 280 exabytes of data. Now, when we come to the recent or current years, you can see that, of course, this previous graph shows that the entire storage capacity, even personal devices, including personal devices. At that time, maybe digital storage devices not that much popular, and people who are not saving that much compared to this digital era or mobile era. 2000 by 2007, you know that there is no smartphone, and we don't have such personal storage capacity in smartphones and the digital devices. It is not so popular, but still at the time we have 280 exabytes of data, which is actually mostly common or like common spaces, not personal spaces. Whereas nowadays we know that we have terabytes of data in our own capacity, or our own personal storage devices are there, which is not included in this graph. Okay, this includes almost internet connected or the worldwide storage capacity on the different data centers, and not the personal storage capacities of your mobile device or your computers were not included in these statistics. Whereas it includes different computational capacities of different databases of social networking, video streaming platforms, and other search engines, etc., and such as cloud storage devices, etc. That, that is accessible through internet. Uh, that is only listed here, and, and just for your information, because our personal storage devices, if you are adding this one, it will be much higher. So it is only internet connected global storage capacity or data center storage capacity is only shown in this graph. And by about 2021, this is an old graph, and maybe about just created as this graph was created in 2017, and that last four graphs were actually extrapolations. So that means predictor of storage capacities. So by this year in 2017, it is predicted that by 2021, about say 2,200 exabytes of storage data will be available in cloud storage devices and other different data centers worldwide. So I through these slides, what I'm trying to tell you is that within a short period, like about 18 to 19 years from 2002 onwards, there is a uh, large scale increase in the overall capacity of the storage devices worldwide, even personal devices also, which is not included in this one. And the data center storage capacities. Data center means Google or such a cloud platforms where such a email or other cloud storage of files were provided. So that type of cloud storage capacity has increased enormously, and now we can see that the overall storage capacity of the data centers worldwide is almost 2,200 exabytes of the data. So that what I want to mention is the volume of the data, or how many bits of data is already stored, or bytes of data is stored in these 2,200 exabytes is more important, because if you want to perform a search, or if you want to extract something, you have to scan properly through this much quantity of the data, so that it is wherever it is available, it needs to be extracted. So it is just like finding something from an ocean, from finding a needle from an ocean, something like that. So that much data is available, and you want to find a very small piece of information, very specifically by adopting some uh, extraction methods or data extraction methods. And there comes the importance of such a data mining techniques. So uh, and I discussed about the data centers. You can see that this is a one of the data center of Google. You can see that it looks like just a very large factory. This is another data center of Google. Google has their own data centers worldwide. In every country, they have their own data centers, and it's some of the data centers of the Google. So see the capacity of the building, and you can see that there are larger pipes connected here. All these are cooling systems for the data centers. So these are some of the data centers. And this is again another Google data center where such computer server computers were arranged as racks, and maybe thousands of racks were there, and each carries a larger capacity, like many terabytes or petabytes of data, and they store our data in such type of data centers. And since you know that even your laptop, if it is working for 24 hours, it will get hot, and such server computers which is working for continuously for a longer period will have high heat generation, and that needs to be cooled optimally. So a simple fan like your CPU, computer CPU, will not be sufficient, and in that case they require highly efficient cooling systems or liquid cooling systems for cooling the entire room and the systems. So there are liquid cooling systems which is used in such data centers. So I just want to introduce such data centers and the capacity of the data centers and the volume of the data that is stored there. And that may be financial information, that may be social networking information, video or network, music, or even your personal data, which is stored in Google Drive. Everything, all the forms of data were nowadays available in such cloud platforms, and which is stored in data centers. And the internet, or the visible part of the internet, actually it works by extracting and finding information from that type of data. And as you know, because anyway, it is not necessary to introduce you to the internet and these concepts. And what you are using actually, it's only a portion of the internet or a tip of the iceberg. And we have unexplored data or unavailable data, which is also known as a dark web, or a hidden web, something like that. And that type of data, even your computer or what is stored in your computer, is also another form of data which is not actually accessible. And there are other internet services which enables you to access that type of data also. But legally available data is actually available throughout the internet. That itself constitutes such a large quantity, and even much higher quantities of the data were available as it may not be available because it is not provided to you, or there will be some physical blocks which disables the proper indexing and making it available. So that's why only what is available in the uh, actual internet or visible internet is available for search and extraction of information for the public. Whereas the overall quantity of the data will be much more higher. So just I was discussing about the quantity of the data which you want to explore. So the data mining. Our topic is data mining. Data mining is it's the process of exploration and analysis by automatic or semi-automatic means the large quantities of data in order to discover meaningful patterns and rules. So you want to automatically or semi-automatically analyze large quantities of data, this much data available in the internet, and you want to discover meaningful patterns and rules so that it will become a useful information. So which is just like extracting a stone and refining it further, and just like refining it to produce some precious stone. It's just like mining a stone. Okay, and that type of effort is required for finding it from a large pool of data, and it needs to be properly processed. Then and finally it should be fine tuned so that that precious stone is created. So it is something like that. The data mining is just like mining a gem. Okay. Now, data mining, in short, we can abbreviate as DM, is a science of finding or mining new interesting patterns and relationships or knowledge in huge amounts of data. So that's the word mean, it's the definition that can be given to data mining. It is defined as the process of discovering meaningful new correlations and patterns and trends by digging into large amounts of data stored in the warehouses. So that's another explanation that can be given to data mining. It's the process of discovering meaningful new correlations and patterns and trends by digging into large amounts of data stored in the warehouses. And what is such a warehouse is already described in the previous slides. So the data mining is also sometimes called knowledge discovery. Knowledge discovery in databases or KDD. So the data mining is not specific to any industry. It is possible for biological science or chemical science or even science in general, or we can apply it in, say, industry or banking, wherever you require such type of, or even nowadays such data, as we know that the sprinkler issue, and such data were nowadays much valuable, and even politicians or political parties were using that such type of data for social engineering. And that type of technology and engineering based on such data and that big data is nowadays available. So the data mining is not specific to any industry; it can be applied anywhere. So it requires intelligent technologies and the willingness to explore the possibility of hidden knowledge that resides in the data. So we require technology and willingness to explore. So that's what is required for data mining. And this approach, data mining approach, is seen ideally suited for bioinformatics since it's data rich, but lacks a comprehensive theory of life organization and at molecular level. It is data rich because we have large amount of sequence data, protein, DNA sequence data available in the database. It is continuously added every day. So there is increasing quantities of the data in bioinformatics, which needs to be addressed. But we have limited understanding on the actual theory of life, how the cells mechanisms will work. We don't, maybe the current knowledge on the actual organization of our life at molecular level will be very minimal. If you have a 100% understanding on all the biological mechanisms of a life, then you can create a cell itself. You don't have to go for another natural mechanisms. If you understand everything, you can create an artificial cell, right? So it is not that our understanding on the life's organization, cellular organization, molecular level is only minimal. We are still discovering it. So to understand that one, you need to analyze that rich data or that large quantity of the data, biological data available in the database. So the extensive database of biological information create both challenges and opportunities for development of novel knowledge discovery database methods. And mining biological data helps to extract useful knowledge from massive datasets gathered in biology and in other related life science areas such as medicine and neuroscience. Not only in general in biology, specifically you can apply it into medicine or neuroscience, wherever such biological data is available, you can apply this technology of knowledge discovery databases so that further information can be generated. Now, there are some historical notes like the development of the terms related with the data mining. So previously in 1960s, we can see that there are some terms like data fishing or data dredging that were used. They were basically used by statisticians, and commonly it's used as a bad name because that is not appreciated at the time. Okay, because data fishing or data dredging is some kind of a there are some statistical methods which may be used for some tricking, and anyway, that is it is not popularly appreciated. The knowledge discovery and database actually they started in 1989, and it is basically used by the artificial intelligence people, machine learning communities, etc. So for that purpose, for developing artificial intelligence and machine learning concepts, then they require knowledge discovery and database, and means they need to analyze the data and educate or learn the machine, or the machine needs to understand the patterns available in the data so that it can perform something. So that pattern recognition is required, or knowledge discovery database is required for artificial intelligence and machine learning. So that was started using in 1989. Then we come to data mining, data analytics, etc. By 1990, database communities, business, financial information, and wherever such databases are available. So various databases were developed and databases were applied worldwide for diverse fields. And in all such fields, we have data mining and data analytics tools available. And that was developed in 1990 itself. But from 2000 onwards, since there is an explosion in the overall quantity of the digital data available, the quantity of the data increased that much. So now we call it as a big data. And our analytics nowadays we call as big data analysis. So that the behavior of an entire population can be analyzed and predicted, or even you can engineer the society based on their taste, based on their requirements, so that they will vote to the concerned person that you decide. So that type of social engineering and manipulation, everything is possible by big data analysis. Not it's not. I'm just not talking about the adverse effects, but it can be used in any way. So big data, the quality of the data that's it's available for social engineering and science and engineering, or financial predictions. Wherever such type of data is available, such big data can be used, and from that patterns predicted from such big data analysis, we can uh, engineer the society, or engineer new concepts. Anything can be done. So the data types, the data types will be structured or unstructured. The structured data means it is properly structured, just in the form of a table, for example. So there we will have some column titles and columns, and which is arranged in columns and rows, as we know. So if you are arranging such a data, for example, if something you are writing on the name field, serial number, name, register number, phone number, address, if you are creating a table, something like that. So what is written in the name field will be recognized, and that cell will be recognized as a name. So the computer can easily look for such fields and locate the name and the corresponding address. So that type of structured data will have an arranged data, and each field will be defined, and the program or the software will be easily recognizing such fields. For example, if you are looking for search in the field name for a particular person, if you are giving such a query, it can easily recognize because it knows the field of name, and the concerned person can be, or the name of the person can be looked in the concerned field. So that's possible because the computer knows, or the program knows, it is the name field. and it is the other one is the address field or the phone number. So that type of data which is properly arranged in a structured way, there is known as structured data. Whereas on the other side, you can see there is a unstructured data, just like a Google page or Google page, sorry, a Wikipedia page or some other page where some information is generally written. So, which cannot be easily interpreted. You can by a computer. So that's another form of data which is known as unstructured data. Compared to the database type data or the structured data, the interpretation or extracting meaningful patterns from unstructured data is quite difficult. It requires further processing because you cannot find the name or a specific name or for example, if I am writing the name of a person and his phone number on the Wikipedia page or a similar page, web page, it will be there will be many names and many phone numbers, and which phone number refers to which one is not mentioned there. The computer cannot correlate that because it is simply written as a plain text. Whereas in the other case of a structured data, the name and corresponding field of a name and phone number, etc., will be in their own rows so that it can be treated as correlated or connected. And so that's the difference between structured and unstructured data. And processing unstructured data may require a little bit of a more effort. So data mining, the general term that the data mining process is actually shown here, and where we have data warehouses. Maybe that is a cloud storage device or some internet storage device, etc., or a server, where such information like marketing or financing, manufacturing or science, whatever, such type of information, even your NCBI GenBank, which stores the genomic information data. So such data warehouse which stores the data will be there. And the second stage is the next process is the selection process. So from the database which stores the data or the data warehouse which stores the data, a proper set of data should be selected based on some queries and other things. There should be a selection process. And once the data is selected, some target you'll get a target set of data for processing. From a large pool of data, some target data needs to be selected for processing. And it needs to be pre-processed. Then after pre-processing, we have the pre-processed data, and that pre-processed data will be used for data mining, and so that it can generate patterns. And that patterns, if you understand the patterns, you can interpret, and that leads to knowledge discovery. So this is the knowledge discovery and database process where the raw data which is stored in the warehouse will be selected, and then some target data there needs pre-processing, and then further data mining. And after data mining, we'll have useful patterns, and patterns will be recognized from that processed data by data mining, which will be interpreted properly so that knowledge discovery can, or new knowledge can be generated from the data. So that's the overall process or workflow of data mining. Now, the first step is the selection process from data warehouse. Then, data exploration is the first possibility. Uh, Data exploration for which you require, you will look into something. What type of data is there? Like how many variables are there in the database? Depends on the independent variables, dependent variables, continuous variables, categorical variables. These are all statistical terms. Anyway, I'm not going to discuss that one. So, what type of variables are? How many variables are there in the data? And how many records are there in the data? For example, the entire genome information, how many number of records are there, and what is the overall distribution of the data. So just an exploration of the data, what the nature of the data and the quantity of the data, it can be explored. And there will be a stepwise the PC or principal component analysis, which is a statistical uh, uh, selection method or stepwise selection method, statistical selection method, that it can be used for extracting some useful information. So the initial stage is to identify the required variables and analyzing the overall quantity of the records and what will be the distribution, etc. So some general patterns or general data exploration is done, and that is the only initial stage. So once it is done, then the data needs to be pre-processed, which includes training data. It needs to be partitioned or divided into some set of training data and validation data. So anyway, you're not to go into the details of the statistical methods, but that second stage of pre-processing will divide the data sets or initially extract a data set into a training data. Usually, machine learning algorithms or such pattern recognition algorithms, they require some training data because, uh, say, you will be given with 10 different examples, and by understanding that 10 examples, you can predict the 11th one. So that's how machine is learned. So a similar 10 conditions will be given, and by analyzing the 10 different conditions or the training data, the machine or the algorithm can generate some regular pattern or general pattern of by analyzing the 10 different training data sets, and the 11th one, a new one, can be predicted based on that one. So that's how it predicts the things. So for which you also require validation data, whether the prediction is true or not. And for analyzing that one, another one for initially there will be a training data set which the program analyzes and understand the pattern. And if the pattern is correct, you can say that, or the mission or the program can say that this will be the possible outcome of the untested one or the 11th one. And that can be verified by and checked with the validation data. So the initial stages of data discovery or sorry data mining is the selection of data from the warehouse or the database and processing and pre-processing of that data. Now, data mining tasks that includes the two high-level primary goals of data mining that in practice are prediction and description. So you need to predict something or describe something. That will be the normal role of such data mining. And the main tasks are classification, estimation, and prediction. Classification means, say, classification is learning a function that maps or classifies a data item into several predefined classes. So you want to group or classify your data. For example, uh, people with age less than 25 and salary greater than less than 40 k, salary greater than 40K drive sports car. So there are statement. So that means the to reach that conclusion, you need to verify that the patient, or sorry, the people age is 25 or less than 25. So you need to analyze all the groups and reach a conclusion. Like the age is 25 and their salary is higher than 40K. So if both the conditions meet, there's a higher incidence of usage of sports car. So by correlating all these things, they can be classified as a group by assumption that they are interested more in sports car. Okay, and or you can group another one like a set of images containing car as an object. So you can analyze all the images and group all the images which contains a car uh, within that image can be grouped together. So any function like such image analysis or classification or grouping of the peoples, etc. These are all grouping based on different conditions. So that is one form of classification of the data. Anything, on any ground you can classify based on marks, based on merit, based on images, okay, like that, or even music, different genre of music. Everything can be classified based on different criteria. So that classification is actually a grouping of the data. Okay, on to predefined classes. And another one, estimation. That given some input data, coming up with values of some unknown continuous variable. So that is estimation. For example, just like the graph of a protein estimation, if you have some input data like one or two variables x and y axis, then you will extrapolate it to the graph, and you will find the value of the protein. Okay, the concentration of the protein can be returned from the graph. Similarly, if you are giving an input, it will come up with the continuous variable, some unknown continuous variable. So something. So because it is having a general pattern, and if you have the two different say values as inputs, based on that values it can easily predict the outcome or the predict, it's not predicted, it's an estimation. because the data is already there. So that's why, just like you are determining the protein concentration, or you're estimating the protein concentration using a graph, something like that. With two different inputs, you can find out the value of the unknown based on that input values. So that's an estimation method. And another one is a prediction. Prediction means same as classification and estimation, except that records are classified according to some future behavior or estimated future value. So prediction means it is not actually done, but that future behavior is predicted based on the input values. So that's also possible. And because, for example, prediction is done for a protein structure. Protein, based on the input values, the possible structure of the protein can be predicted. So that's another method. So prediction, estimation, classification. These are all some of the data mining tasks, and this is one category. There is another one, that is association rules, for example, determining which things go together, and also called dependency modeling. For example, 80% of the images containing a car as an object also contain blue sky. So that's an association between blue sky and images containing a car. Also, 98% of the people who purchase diapers also buy baby food. So there's a connection or dependency between baby food purchase and diaper purchase. Okay, so that means the data can be analyzed in such a way that it can find the association between two things. So that's known as association rules. And also another one is clustering. Clustering is segmenting a population into a number of subgroups and clusters. So that is another one. That is a clustering, segmenting a population into a number of subgroups, dividing it into subgroups. Then description and visualization, that is representing the data using visualization techniques, just by generating graphs and other things. So that's another one. So these two slides, that is the first one, classification, estimation, and prediction. This belongs to one category, and association rules, clustering, and description visualization. This belongs to second category. So learning from data falls into two categories. One is directed or supervised, and the second one is undirected or unsupervised learning. So the directed learning and undirected or unsupervised learning is there. The first three tasks, that is classification, estimation, and prediction, are examples of supervised learning because we use an input and output data. We have an input and output data. Both are used in case of the first three categories, the classification, estimation, and prediction. We have the complete input and output data. Okay. Whereas the next three tasks, association rules, clustering, and description and visualization, they are examples of unsupervised learning. So there we have only input data. They need not be classified or labeled or categorized. So this input data is only available. The output data is generated by the computer as a prediction. So it is it is generated by the computer, not a prediction. Prediction is another term that is used in the first task. But that clustering or so we analyze the data, input data, and then it generates the something. So that output data is not a part of the input, or it is not actually present in the database in the second case. So association, prediction of associations. By analyzing the data, the associations where the information related with association is generated by the computer or the program. So that is a unsupervised learning. Whereas the previous one, that is where we have input and output data, both are available, like classification, estimation, and prediction. They belongs to directed or supervised learning. Now, in unsupervised learning, no variable is singled out as a target. The goal is to establish some relationship among the variables. Unsupervised learning attempts to find patterns without the use of a particular target field, and the development of new data mining and knowledge discovery tools is a subject of active research. One motivation behind the development of these tools is their potential application in modern biology. So we have various methods of data mining, like as I mentioned, classification, prediction, then estimation, then finding the associations between some two groups, then clustering into subgroups, and also generating interpretations and visualizations based on the data. So that type of data mining tasks are there. which can be placed under directed learning or undirected or unsupervised learning. So this is having more applications in biology. The information retrieval, and that is another part. So existing problems can be categorized as the absence of. For the information retrieval from a large database, this can be listed as the problems associated with such information retrieval. One is filtering. A user looking for some topic on the internet receives too much information. If you give a query into an internet search box, you will get maybe millions of search results or hits. Probably you will be looking into a three or four top ranking list, and the remaining 1 million or some will not be addressed by you. So that may not, you are not even going for the second page of Google search result. So in that case, um, you are getting too much of information which you are not interested to look forward. Okay. So a proper filtering of your data or your query is required so that the most useful information out of this 1 million query results needs to be filtered and available or placed on the top of the query results. Okay, that's one problem of information retrieval. So there is a large amount of information, and from which uh, locating what you're looking for is a Herculean task. Then ranking of the retrieved documents. The system provides no qualitative distinction between the documents. For example, there is a 1 million search result in Google, and how it is ranked, which one is placed on the top, because you are looking only on the first page, at least three or four or five results, and you are not going down the page or scrolling down the page or moving to the next page. So if you will look into the document only when it is placed with a high rank or highest priority on the top of the list, then only you will be clicking on that link. So how it is done? Usually there is no qualitative distinction between one site and the other. The computer doesn't know, or the Google doesn't know that. But of course, there is another method. There are paid listings in Google or such services where such paid services will be listed on the top of the query result. Whereas the other ones, which is freely available in the internet, or those who don't pay for the Google, may be placed on, below the query results. So that is one fact actually we are facing. Anyway, ranking of the retrieved documents is another problem. How will you qualitatively assess because they need to understand the user preferences and or the taste of the user. Then only qualitatively it can be assessed, and the proper document that you're looking for can be placed on the top of the list. Okay. Now, support of relevance feedback. So the user cannot report his or her subjective evaluation on the relevance of the document, because Google or any such search engine will not ask for your feedback. Whether the query, of course, in some cases, previously it was there. Are you satisfied with your query result, or did you find what you are looking for? Such type of survey type analysis were done by Google also, because to ensure that the proper document is actually made available on the top of the list, and to understand the user preference. Are you satisfied with the query result, or yes or no? That type of feedback were later added. But usually, such a query or search results may not provide any uh, feedback provision. So usually, the server or the program won't understand whether the relevant document is delivered to the user or not. And another one is personalization. There is a need for personal systems that serve specific interest of the user and build his user profile. So that's also required, because uh, maybe one person is searching for a particular virus, and that name of the virus, maybe I am looking for, one person is looking for COVID-19, for example, and a medical practitioner may be looking for some treatment aspects. Whereas a molecular biologist may be looking for is genetic information and concerned sequence information. And another one may be looking for a pharmaceutical company may be looking for some drug targets or possible drugs that is related with this COVID-19. So, depending upon the user, the same query type, COVID-19, uh, will have to return a different result. That personalized result is, or it can be made available only if the system understands the user preference. So there comes. So nowadays, you know that there is a cookies, some type of scripts which is available in the website. They were using that cookies. Cookies means it stores your search histories and other informations. So based on which the search engine generates a pattern of your profile, and that based on that pattern and the different search terms that you are using, it will correlate that terms and it will understand your taste. So later on, if you visit Google, for example, you are looking for say pulse oximeter, you are searching for that one, and maybe you are looking for the applications or the working mechanism of the pulse oximeter. But after some time, if you visit Google, uh, you will have an advertisement on the site that from a company which sells pulse oximeter or related products or some other ventilator products that will be made available to your search result as an advertisement. How this search engine understands that? Because they keep a personalized profile and they know what search terms or query terms were used by you in the previous days. So based on which the server or the software understands that this user is now interested in this particular item. So a product related with that one or a similar item needs to be shown as an advertisement. They decide also the query results. Actually, they were served by Google and such engines as a personalized result based on your query results and patterns that is generated based on your interest. The next one is adaptation. The system should notice when the user changes his or her interest. So usually the search pattern that also changes. Previously, last month you may be interested in something, and this month you may be interested in something else. So the system also should again it should adapt that based on your query patterns and other things. Your changing interest needs to be understood by the system so that proper information or relevant information may be delivered to the concerned user based on that changing interests. So this is also done, and these are some of the areas that is addressed while retrieving the information from the internet. Now, four main constituents can be identified in the process of information retrieval from the internet. One is indexing. Indexing is the generation of a document presentation. For example, there may be millions of web pages in the internet or such documents in the internet. So you need that you know that when you type some query term in Google search box, it will automatically suggest the list of query terms. By typing a few words, a few letters, it will give you a list of the query terms or such questions. Okay, and Google actually what they do is that they are not searching the internet based on your query. So for example, you are giving say COVID-19 in Kerala, so you are just giving a query term. So the Google will not actually in real time searching all the internet, maybe billions of pages available in the internet for your search term in real time. It's not like that. They already have an index of all the documents available in the internet. Whenever a new document or new website is or new page is added, Google will run some search boards. Search boards is search scripts, which will analyze all the newly added pages in every website and create an index of each term or each word created or used in that concerned document and create an index of such words and keep it in their database. So when you are searching for when you are searching internet or Google with a query term, Google is just looking into their indexing table, not on the overall internet. Okay, in real time, because sometimes the server may be down. Yeah, in real time that might not be listed. But every page in the internet is actually indexed, and a list of the words of every page is kept as an index file in Google database. So when a query is made available, such indexing that word it will be matched, or index will be matched with the query, and all the pages which is listed in that index or connected with that index will be listed to you within milliseconds, within a time of milliseconds. So that's how indexing works. Now, uh, querying is the second term. Querying, that's an expression of user processes through natural language or terms connected with the logical operators. So querying is the actual process of submitting the search. For example, you can give a search term like COVID-19 in Kerala. So in will be ignored. COVID-19 and Kerala can be treated as two separate search terms generally. So it will list all the pages with COVID-19 and Kerala, both. But if you are placing a double quote to the entire term, COVID-19 in Kerala, it will look for the exact phrase COVID-19 in Kerala in the database. So designing such a logical, such a Boolean operators, such query terms with Boolean operators or logical operators is always required to filter the results. Otherwise, the Google may list a few million results with COVID-19, another few million results with Kerala. That will be separate results, but it will be listed in the same page. So to avoid that, combination search terms needs to be used. So the query is actually the expression of the user's preference in natural language. That means English, and that needs to be connected with the logical operators like and, or not, and double quotes, etc. So that type of search needs to be used for a exact for filtering the results and getting exact information. Then the evaluation. Performance of matching between user query and the document representation is the evaluation. So, user query is there, and our document presentation or the document stored in the internet is there. So that needs to be properly matched, and the top scoring documents needs to be placed on the top of the list of query results. Then user profile construction, another one. Storage of terms representing user preferences, especially to enhance the system retrieval during the future access by the user. So, if a medical person is searching the internet with COVID-19 for the last 1 week, it will generate a pattern from that user, and subsequent results will be based on medical field only. And if some industrialist or some other working on COVID-19, and based on his search patterns, such results will be delivered to him based on his user preference. And that's why such a search engines were generate user profiles uh, based on cookies and other search patterns. So this is how the information is actually retrieved from the internet. Now, for which these data mining tools were used, we have various statistical softwares and other packages. The most popular one, which is a free tool, that's R, then Python, SQL. Excel is a simple one, which is not used in the server side. Then RaidMiner, and there are a lot of other packages. The most popular one is still that's the R package, which is a statistical package. So in 2016, these are the top 10 tools that is used for data mining. And the Python and SQL, they are also uh, popular. Python is a popular language. SQL is also a structured query language. That's a database search language, which is widely used for data mining. Now, when we come to the application of data mining in bioinformatics, we have various applications in the fields like gene finding. Gene finding means to locate the position of a gene in a large pool of database. Maybe there are uh, thousands of entered genomes were available in the NCBI database. If you want to find a particular gene, of, for example, human gene in 3 billion base pairs, the start and end of the gene, you can use such data mining tools for gene finding. Protein function and domain detection. So you can predict the function of the protein, then the domains of the protein, etc., can be determined using such tools. Function motif detection, then protein function interference, disease diagnosis, disease prognosis, disease treatment optimization, then protein and gene interaction network reconstruction, then data cleansing or cleaning, then protein subcellular location prediction. So various fields are there. There are a lot of fields are there, and in which you can use such data mining tools in bioinformatics, and there can be means these are different types of data. DNA sequence information, protein sequence information, protein structure information, motif information, function networks, then metabolic pathway network, then disease information networks, then the protein-protein interaction studies, that type of databases, all are available, and there you can use such data mining tools for extracting the information. For example, microarray technologies are used to predict a patient's outcome. On the basis of patients' genotypic microarray data, their survival time and risk of tumor metastasis or recurrence can be estimated. So that's one type of usage of data mining. So microarray technologies actually it analyzes the entire gene expression profile. All the mRNAs expressed in a sample in a patient can be simultaneously screened for gene expression to analysis of the gene expression, and that needs to be properly processed. So on the basis of this patient's genotypic microarray data, the survival time and risk of tumor recurrence, etc., can be estimated. So that is one of the applications. Then machine learning can be used for peptide identification through mass spectroscopy. So usually in mass spectroscopy, what, for example, a protein is a protein, purified protein is given to mass spectroscopy. Usually mass spectroscopy will break down that into different fragments. That entire larger molecules or peptide will be broken down into it will be fragmented using the different methods, electron spray ionization or different methods. And that fragments, each fragments, the mass of each fragment will be determined by the machine. So you will get a spectrum of different masses. So the larger protein will be broken into maybe hundreds of different smaller fragments, and each fragment will be determined for its mass, and you will have a spectrum of different masses with different peaks, and that can be analyzed. That mass can be analyzed, or the spectrum of mass that is generated can be analyzed, so that the peptide can be identified using this MS. So for peptide identification, you can use such a tools using mass spectroscopy. And correlation among fragment ions and in a tandem mass spectrum is crucial in reducing stochastic mistakes and for peptide identification by database search. So this is some of the applications. It can be applied for tumor diagnosis and disease treatment, like microarray analysis, or we can identify the peptides using analyzing the mass spectrum of the concerned protein, and that is also another example. So these are some of the general concepts about the data mining. So different types of data mining tools applied in bioinformatics will be discussed in our practical sessions and things. So you just need to understand what is data mining and the basic theory behind that. Now, as far as we are concerned, our biological data, we'll see each forms of data in the subsequent sessions, and that can be properly analyzed, retrieved, and proper information can be generated from analysis of data. And data mining is the core concept behind the extraction of data from such large databases or huge databases. Any doubts?